Another formal method that allows us to detect multicollinearity in our dataset is the so-called condition index. On this slide, you can see the formula which allows us to calculate it. So the condition index is equal to the square root out of k variable, which is equal to the square root out of maximum eigenvalue divided by the minimum eigenvalue. When it comes to the eigenvalue, you don't need to worry about it because this is the value that is provided by the software. So what you will need to do is just calculate the condition index. And if k is estimated to be 100 and 1000, then we say that we either have moderate multicollinearity, and the closer we are to 1000, the stronger multicollinearity is. And if it happens that k is higher than 1000, then this is the case of very severe multicollinearity. Alternatively, we can interpret the condition index itself. If it lies between 10 and 30, then there is moderate to strong multicollinearity. So the closer we are to 30, the stronger multicollinearity is. And if it happens that the condition index is higher than 30, then we've got the severe multicollinearity. And the last formal method that I would like to present is the so-called variance inflation factor. This is an example how it can be calculated quite easily. So this is just 1 over the difference between 1 and r squared, where r squared is the coefficient of correlation between x2 and x3. Luckily for us, we don't need to calculate variance inflation factors ourselves. They are automatically calculated by the software. So we'll just go into this variance inflation factor results and look at the values. And if the variance inflation factor of a certain variable exceeds 10, so if it is higher than 10, then we say that that variable is highly collinear. If it is lower than 10, then we say that the variable is not collinear and it can stay in the model.